Okay, hello everybody. Thank you for watching my video. So today we will be discussing about CIE A-level math past papers February March 2020. This is for JC students. This is the pure math 3. So let's go start. This is question number 8. In the diagram, OABC, OABC, DAFG, DEFG is a cuboid with in which OA 2 units. This is OA. The length of OA 2 units, OC 3 units, from O to C 3 units, and OD 2 units. This is the vertical sides, that is 2 units. Now, unit vectors I, J, and K are parallel to OA, OC, and OD respectively. This is I, that is unit vector in the direction OA, J is the unit vector in the direction OC, and K is direction vector in the direction OD. The point M on AB, this M lies on line AB, is such that MB equals to AM. Thus MB to twice AM. Thus the point of the midpoint of FG is N. Thus the midpoint of FG, that is N. Yeah, thus the length of this one equals with the length of that one. Now, question A. Express the vector OM and vector MN in the terms I, J, and K. Now, first, MB equals to AM. MB equals to AM, thus MB divided by AM, that is 2 equals to, or that is 2 to 1. Thus MB, thus MB to AM, thus if this one 2 units, this is 1. Thus a total 1 plus 2, 3, that is why AM per AB, that is 1 divided by total AB, 1 plus 2 is 3. Thus AM is 1/3 AB. Yeah, okay. Now vector OM, yeah, vector OM is here from O to M. Yeah, this is the vector OM. No, from this figure you can see that vector OM equals vector OA plus vector AM. Yeah, thus vector OM equals vector OA plus vector AM equals vector OA plus AM. Vector AM, that is 1/3 vector AB. That is why here vector AM is equals 1/3 of vector AB. That is, and vector AB will be equals with vector OC, because AB equals in length and OC, and the direction of AB equals the direction of OC. Thus, now vector OA, that is 2I, because the length of OA is 2. And then unit vector is I, thus vector OA is 2I, and OC, that is the length is 3, and the unit vector J, 3J, thus 1/3 OC, that is 1/3 times 3J, thus equals to I plus J. Thus the vector OM, or position vector M, that is 2I plus J. Now vector MN, this is the vector MN from M to N. Now you can see in this figure that vector MN will be equals with vector MB plus vector BF plus vector FN. Yeah, thus vector MN equals vector MB plus vector BF plus vector FN. Now vector MB, that is 2/3 of vector AB, or 2/3 of vector OC, and vector BF that is equals with vector OD. Yeah. And vector of Fn that is half vector OA because vector OA equals vector GF, but here Fn is in opposite direction with vector OA, that is why will be minus half vector OA. Yeah, thus vector MB 2/3 vector AB plus BF is that is equals vector OD and vector Fn that is minus half vector OA because that is in opposite direction with I direction, half OA. Now 2/3 AB is that is equals OC 3J and OD that is 2K because the OD is 2 units and the direction vector is K. And then OA again is minus half 2 times 2I. No, until simplification, minus half times 2I that is minus I, plus 2/3 times 3J that is 2J, and plus 2K. Thus this is a vector Mn. B, find a vector equation for the line through MNN. Thus the equation is find the vector equation of this line. Line pass through point M and point N. Now, the line pass through point M with position vectors, yeah, already calculate in A, vector OM or position vector of M that is 2I plus J, and the line MN that is in the direction of vector Mn itself or parallel to the direction vector of Mn. So the vector equation for the line through MNN, that is the line pass through a fixed point M, that is the position vector is 2I plus J, and the direction vector that is the direction vector of Mn, that is minus I 2J plus 2K. Thus the vector equation for the line through Mn that is R equals to I plus J plus lambda times minus I plus 2J plus 2K. Lambda belongs to real numbers. Yeah, thus the vector of equation of the line that is has a fixed point and direction vector. That the fixed point that is point M. Yeah, you can also choose the for point N, but in this equation the fixed point that is point M and that is the direction vector of vector Mn. Thus this is the answer for B. Question C. Find the position vector of P, the foot of the perpendicular from D to the line through M and N. Thus now this is three-dimension diagram is reduced to the two-dimension diagram here, that is in the plane, so that that is more clearly to see the position of point D, M, N, and point P. Now, vector equation of this line MN, that is already found in question B. That is the R equals, that is the fixed point M, coordinate of that is a vector form of the position vector of M, that is 2, 1, 0 plus lambda times the direction vector minus 1, 2, 2. Now, we draw line DP. Here P, the line DP is perpendicular to line MN, and this is point P. P is called the foot of perpendicular from D to the line MN. Now, there is a value of a lambda, so that P exactly lies in this point. Now, we can find or solve the lambda by using the dot product of vector dv and vector mn. Now, because vector dv perpendicular to vector mn, thus vector dp dot direction vector of line mn, that is minus 1 to 2, will be 0. Dus vector dp dot minus 1 to 2 equals 0. Now vector dp, that is position vector of p minus position vector of d, that is op minus od. Now p here we have if the coordinate of point p here, that is 2 minus lambda, 1 plus 2 lambda, 2 lambda, and the position or position vector of the coordinate of point d, that is 0, 0, 2. Yeah, that is the here. Thus that is in I direction 0, in j direction 0, and in the k or vertical direction 2 units. That is why the coordinate of point d is 0, 0, 2. Now vector dp is vector op minus od. Now op, that is, this is the coordinate of point p, 2 minus lambda, 1 plus 2 lambda, and 2 lambda minus the coordinate of point d, that is 0, 0, 2, 0, 0, 2. And that is 2 minus lambda, 1 plus 2 lambda, 2 lambda minus 2. Now this is the vector dp. This is a direction vector of line mn. This one dot this one will be 0. 1 minus lambda times minus 1, this is minus 2 plus lambda, plus 1 plus 2 lambda times 2, that is 2 times 4 plus lambda, and then plus 2 times 2 lambda, 4 lambda, and 2 times minus 2 minus 4 equals 0. And lambda, 4 lambda, that is 9 lambda, minus 2 plus 2, 0, minus 4 shift to the right, thus 9 lambda equals 4, thus lambda is 4 over 9. Now the position vector of p, that is op, just substitute lambda by 4 over 9, that is the component x, that is 2 minus lambda, 2 minus 4 over 9, component in the j direction, that is 1 plus 2 times lambda, lambda is 4 over 9, 1 plus 2 times 4 over 9, then in the k direction, that is 2 lambda, 2 times 4 over 9. Thus the position vector of p in component form, that is 49, 17 per 9, 8 per 9, and then in the unit vector form, that is equals 4 over 9i plus 7 per 9j plus 8 per 9k. Thus this is the answer for question C. That is all for this question today. See you in the next video. Thank you.